Welcome to the Explainer. You actually use artificial intelligence every single day. Think about it. When you pick up your phone and it unlocks with just a glance at your face, that's AI. When Spotify perfectly guesses your mood and cues up the exact right song, yup, AI. Or when you use ChatGPT to help outline an email or summarize a really long document, that is AI in action. But have you ever stopped and thought, wait, how does this actually work? What is mechanically happening inside these complex systems to make them seem so unbelievably smart? Well, today we're going to explore exactly how AI works, step by step. And I promise you, we're going to completely demystify this engine together. No complex math, no writing lines of code, just pure, clear understanding. So, how does AI actually work? Let's dive right into this core question. We're going to peel back the layers of the AI engine to see exactly what happens when you type a prompt into something like ChatGPT or upload a photo to your phone. I know it can absolutely feel like pure magic sometimes, but I assure you it is simply mechanics.
Section 1. The foundation. The universal three-step process. To kick things off, we need to realize that literally every single AI system out there, no matter how insanely complex or surprisingly simple it might seem, relies on this exact same universal three-step cycle. Step 1 is the input. We just give the AI some information. This could be a text prompt, an image, your voice talking to a smart speaker, you name it. Step 2 is processing. Now this is where the AI gets to work. It looks for patterns, it runs calculations, and it figures out what your input actually means. And finally, step 3 is the output. The AI gives you an answer, a recommendation, or makes a decision. That's the entire flow. But the true intelligence, the actual magic of the whole system, happens entirely right there in the middle in step 2.
Section 2. The engine, learning through examples.
Now, let's zoom in on that processing step. The engine itself. This brilliantly illustrates the huge difference between old technology and new technology. In the past, if you wanted a computer to recognize a cat in a photo, a human programmer had to sit down and write hundreds of rigid rules using traditional programming. They'd have to type out instructions like, okay, if it has pointy ears and whiskers, then it's a cat. But what if the cat is facing away? Or, I don't know, what if it's just a guy wearing a pointy hat? The system completely breaks down. It would constantly fail. AI doesn't come pre-programmed with answers like that. Instead of writing rules, we use a process called AI training. We simply show the system a million photos of cats and a million photos of things that are absolutely not cats, like dogs, cars, trees, whatever. Every time we show it a photo, we tell it this is a cat or this is not a cat. By doing this over and over, the AI learns the patterns entirely on its own. So, this massive collection of examples, those millions of photos or billions of sentences, is called training data. The AI uses this training data to figure out features like fur texture or body structure or eye shape, all without a human ever defining what a whisker actually is. And there is one absolute golden rule you have to remember here. Better data equals smarter AI. Garbage in, garbage out, right? This is exactly why the AI tools you use at work are only as good as the information they've been fed. The quality and volume of this training data dictate literally everything.
Section 3. The microscopic view. Inside the digital brain.
Okay, so we know it learns from data, but what is actually happening microscopically inside this digital brain, the neural network, when it looks at one of those cat photos? Well, as an image enters, it passes through layers of connected nodes. The very first layer is incredibly basic. It isn't looking for a cat yet. Layer 1 simply scans for basic edges, straight lines, and simple curves in the image. Then, in a fraction of a millisecond, let's see how this builds in layer 2. The neural network takes those basic lines and edges from the first layer and starts combining them. Now, layer 2 is looking for fundamental geometric shapes, things like circles, ovals, and triangles. The flow just keeps moving through subsequent layers. Layer 3 takes those simple shapes and combines them into distinct features. So now it finally recognizes an eye, an ear, or a nose. Then, layer 4 takes those isolated features and pieces them all together into a full object, like a complete cat face or a furry body. Finally, the very last layer in the network takes all of this compiled information and makes the ultimate decision. Yes, this is a cat, or no, definitely not. But wait, how does it know if it made the right decision? This brings us to a really fascinating concept. Every single connection between those nodes we just talked about has a number attached to it, and this number is called a weight. I want you to think of weights kind of like the volume dials on a radio. When the AI is training and gets an answer wrong, say it totally mistakes a dog for a cat, it goes back and slightly adjusts those dials. It turns some up and turns some down. This specific adjustment process actually has a technical name, backpropagation.
Now, you don't need to memorize that word, but you do need to understand the core concept. Backpropagation is simply the process where an AI learns by making mistakes. It makes millions and millions of mistakes, and every single time, it slightly adjusts its dials to fix them. Each wrong answer is a tiny adjustment. Each right answer confirms the current dial settings. After billions of adjustments, the dials are perfectly tuned, and the AI gets it right almost every single time. It learns exactly like we do as humans, through trial, error, and repetition. It's kind of like learning to ride a bike, except you're falling off a million times in 5 seconds.
Section 4, Real-World Application, How ChatGPT Actually Works.
All right, let's take everything we just learned about training data, recognizing patterns, and adjusting those dials, and apply it to something you have probably used, ChatGPT. To train it, OpenAI fed it a massive, almost incomprehensible amount of text. We're talking books, articles, websites, research papers, hundreds of billions of words representing a massive chunk of the entire internet. It didn't memorize this text, though. It learned patterns. It learned that when a human writes a specific kind of sentence, a certain word usually follows. Which brings us to a secret that usually blows people's minds. When you type a prompt like "the sky is," the AI isn't actually thinking about the sky at all. No way.
It just outputs blue. And this brilliantly illustrates what ChatGPT is at its core. It is just a staggeringly powerful prediction machine. It writes blue because, out of the billions of sentences it studied during its training phase, the word blue is statistically the most likely word to follow the phrase, "the sky is." Every single word it generates, whether it's an email, a poem, or a complex code snippet, is simply the AI predicting the most likely next word based on those perfectly tuned dials in its neural network.
Section 5. The context. Why AI exploded right now. So let's zoom back out for a second. If this math, this whole concept of neural networks and weights, has existed in computer science for a while, and it has, why is AI exploding right now? Why wasn't ChatGPT a thing 20 years ago? Well, the first and absolutely most critical answer is data. Remember our golden rule? Better data equals smarter AI. Thanks to the explosion of the internet, social media, and having a smartphone in everyone's pocket, humanity now generates an unfathomable 2.5 quintillion bytes of data every single day. That is a massive ocean of data. Every click, every photo, every search, it's all fuel. We finally have enough training data to actually teach these massive neural networks. To sum it all up, it was really a perfect storm of 3 major factors. First, that massive explosion of data we just talked about. Second, computing power. It turns out that GPUs, the graphics cards originally designed to make your video games look good, are exceptionally perfect for the billions of tiny mathematical calculations that AI requires. What used to take years to process can now be done in days. And third, better algorithms. In 2017, a revolutionary new way to build neural networks called the transformer architecture was invented. This allowed AI to understand context in language far, far better than ever before. Those 3 pillars, data, computing power, and algorithms, combine to ignite the AI revolution we are living through right now.
So there you have it. You now understand the mechanical reality behind all the magic. You know that it all boils down to input, processing, and output. You know that AI learns from vast oceans of training data, identifies patterns through layers of a neural network, and constantly tunes its styles by making and fixing millions of mistakes until it becomes a flawless prediction machine. But as we wrap up this explainer, I want to leave you with a thought to really ponder. As we generate even more data, invent even faster chips, and design even smarter algorithms, these systems are only going to get better at predicting exactly what comes next. So the ultimate question is this: what happens when the prediction engine becomes entirely indistinguishable from human thought? Thanks for joining me on The Explainer today. I'll see you next time.